In this video, you'll learn how to create a dot plot. A dot plot is often considered a useful alternative to a histogram. This data set shows the wash cycle time for 40 washing machines. We want to know how the data are dispersed along the scale from minimum to maximum wash time. When we are finished with this data set, our dot plot will look like this one. The x-axis is the number of minutes in a washer cycle, and the y-axis is the frequency with which a particular number of minutes occurs. This point, for example, at 35:3, which does not have a value above it, means that 3 times 35 minutes occurs in the list of 40 results. Before we can build this chart, we first have to prepare our data to get the frequency count. I've already sorted my data from largest to smallest. Now I'm going to add another column called frequency count. I'll use a simple formula in the frequency count column to keep count for us. The first part, A1 equals A2, that's what my if is looking for. Does the value in A1 equal A2? If yes, use my then part of the formula, which says, then add a 1 to my frequency count. Note that it's pointing to the cell just above this one in the frequency count column. And finally, if A1 does not equal A2, we get to the otherwise part of the formula. Otherwise, put a 1 here. Of course, starting at the top of my numbered list, I know that A1 doesn't contain a number. Therefore, we should have this 1 returned for us. With the formula set up, I can either drag it down the column or double-click the bottom right corner, and it will populate all the way down the column. Let's do that. Let's check a couple of the results. 48 occurs twice, and as you can see, the first time it's counted as a 1, and the second time it's counted as a 2. Here's another. 42 occurs 3 times. Now it's time to insert our graph. Select columns A and B, go to Insert, Charts, All Charts, XY Scatter, and this frequency count will be our dot plot. Note that it already looks a lot like the graph we showed at the beginning of the video. We could stop here, but we have some cleanup to do. Our numbers are bunched together so tightly it's hard to untangle. We don't need half numbers on the y-axis. This is our frequency count. We can only have frequency occur once, twice, 3, 4, etc. Right-click on your graph and choose Format Plot Area. We'll first change the primary horizontal axis. I'm going to move the graph over so that we can see it. Click on the bar chart icon. Under Axis Options, change minor units to 1. Change the bounds to a minimum of 25. We don't have any values very far below that. And you can see already that the dots spread out. Now we move to the primary vertical axis. And on the primary vertical axis, let's change the minor units to a 1 and the major units to a 1. Our maximum value is a 4, so we can go ahead and change that as well. Now we can close this sidebar in order to have some space. I'm moving the graph to the left so that we can see all of the options. Click the check mark, go to Grid Lines, and where it says Minor Vertical, when we click it, you can see that it fills in faint lines on the graph that make it easier for us to see where dots are placed. We're almost done. Now we just need to change frequency count to the title that we want to have here. That's more descriptive. We'll change that to washer minutes, and we are done. In this video, we have walked through how to use the if function to create a frequency count of the values in a set of data, and then, using the XY scatter chart, build a dot plot. In this video, we will build a scatter plot to visually determine whether there is a relationship between two quantitative variables. The data shown here represent a sample of homes sold in a 1-month period. The size column is the square footage of the home in thousands. The selling price is also in thousands. We want to know whether there is a relationship between selling price and size of home. The best graph to demonstrate the relationship between two quantitative variables is a scatter diagram. When we are done, our diagram will look like this one. Each dot represents a single combination of a selling price and square footage. Our x-axis is typically used to represent our independent variable if we believe one variable influences the outcome of the other. In other words, if we believe that the larger the home, the higher the selling price, we would put the square footage on the x-axis. Let's select both columns, go to Insert, Chart, All Charts, and XY Scatter, and then we'll click on the option that says Selling Price, and click OK. It's already quite similar to our final diagram, but let's consider a couple of things. We have a large chunk of white space because our axes start at 0, but no home will sell for 0 value or 0 square foot, and you also don't see the red circles that indicate some duplicate values exist. I'm going to delete this graph, and now I'll add a new column called Duplicates. And what I'm going to do with my formula is tell Excel to look in the A and B columns, and if there are any exact replicates of a coordinate, and by coordinate I mean an XY value, tell me about it in the duplicate column. I will do that with a combination of the if and sum product formulas. Here's the formula. Pause the video to copy it down. Now I'm going to build it in the cell and walk you through how it works. We're using sum product to look up duplicate numbers in the column. If Excel finds another instance in the A and B columns with this exact combination, for example, if there's another 0.8 and 85, then Excel will enter the selling price value in column C, otherwise it will put NA. The format of NA with 2 parentheses in the formula is on purpose. When we graph that, Excel will ignore any NA values. Let's go ahead and hit enter, and you can see that NA is indicated here because there are no duplicates of 0.8 and 85. I'll pull this down the column, and you can see that there are 4 cells in the duplicate column that have a number in them for selling price, because we have 2 duplicates for 2 coordinates. Now it's time for us to select all 3 columns, Insert, Chart, All Charts, XY Scatter. We'll pick the second option, OK. And now we have a couple of things to do on the graph. We can first delete the legend, we don't need it. And then we'll right-click and choose Format Plot Area, and we will select Series Duplicates. Under Marker, we'll change the marker options to built-in and to size 8. We'll change the fill to no fill, and we'll change the border to solid line, and we'll make that red. And when we click away from this, when we close this, you can see that we now have the red circles around the blue dots to indicate duplicate values. Change our chart title to square footage versus selling price. Right-click on my chart, Format Plot Area, and under Plot Area Options, I will select the horizontal axis. You can see that it is selected on the graph here. I'll move it over so we can see the whole thing. Of course, we have nothing that's at 0 square feet. I've chosen horizontal value axis, and I'll click on the bar chart. Under Axis Options, I'll change the minimum to 0.7, and we'll leave the maximum at 1.5. We now select the vertical value axis. Let's change our minimum to 60, and we can leave our maximum at 130. As we look at this graph, we can see that the dots do tend to spread out as square footage increases, moving upward and to the right, although there are some houses that are selling at lower prices despite being at larger square footage. And this is where having the circles to indicate duplicates becomes helpful, because we can see that there are more houses overall that are more money for larger square footage. In this video, you have learned how to build a scatter plot showing duplicate values as red circled dots. In this video, you'll learn how to create a stem and leaf diagram in Excel. A stem and leaf diagram, also called a stem and leaf display, displays the frequency of quantitative data observations in a condensed form. This data set shows the wash cycle time for 40 washing machines. When we are finished, our stem and leaf display will look like this. At a glance, you can see that more wash cycles required 40 or more minutes than 30 or more minutes, and 20 or more minutes had the fewest wash cycles. Excel does not have a template for creating this type of diagram, but with a simple, although long, formula, we can quickly build one. For convenience, I have sorted my values from smallest to largest, but the first thing I need to know is, what are my min and max data values? Even if I hadn't sorted the data, I could find that out quickly using the equal min and equal max formulas. Here I can see that my minimum value is 26 and my maximum is 48. And the reason we care about that is because this tells me how many values I'm going to have on the stem side. In my stem, I'm going to need to represent values that are in the 20s, the 30s, and the 40s. Now I'll set up a stem column, and since I only have numbers that go to the tens places, I'll assign 2, 3, and 4 for my tens places, and I'm going to add a thick border to offset my stem from the leaves, which is the traditional way that you see a stem and leaf display. Here is the formula that we are going to use. REPT stands for repeat. COUNTIF says if a number I've specified shows up in my data, count how many times it does. You may want to pause the video and copy this formula. I want to know how many times 20, 21, 22, 23, etc. through 49 appear in my data. I'm going to build a formula that I can copy down to the 3 and 4 rows. The formula I'll type is equals REPT, parenthesis, quote mark, space, 0, space, quote mark, comma, COUNTIF, parenthesis. I'm going to select the A column, comma, and then I'm going to select this 2, that's my stem for 20, times 10 plus 0, close parenthesis, and another parenthesis. This is the first part of the formula. It says put a 0 in this cell for as many times as you find 20 in my data. This COUNTIF part tells Excel what it is looking for. It's going to go to the A column, and F5 is my 2. You can see that I've told it to multiply the 2 by 10 and add 0, which works out to 20. That's a complicated way of saying 20, but I'm going to show you how to copy and paste this entire chunk of formula without having to type, look for 21, look for 22, look for 23. Also, that space that's before and after the 0 that's in the quote marks is because I want to separate my results. That space in the quote marks will keep the numbers separated from each other. Now, I'm also going to need to insert the results for how many times it finds 21, 22, 23, etc. I'm going to use the AND symbol at the end of my formula. Now that I have that, I can copy and paste all the way back to REPT. I don't need the equal sign. Control C and then Control V. And now I can change that 0 to a 1, and I'll change this 0 to a 1, and I've just told Excel count how many times you find 21. Then paste it again, and when I paste it again, I would change that to a 2 and then to a 3. Notice I got rid of that last AND sign that was at the end of the formula. I don't need it. And now I hit enter, and as you can see, it's telling me that in my data values I have 26, 26, 27, 27, 28, 28, and 29. Now that we've typed the formula in once, we can drag it down, and here we've got our stem and leaf diagram. This video demonstrated how to build a stem and leaf display, also called a stem and leaf diagram, in Excel using the REPT and COUNTIF functions. In this video, you'll learn how to use Excel's percentile and quartile functions. In this dataset, the spend on food and drink by 40 families at an amusement park has been recorded. For convenience, I've already sorted the data from smallest to largest spend. I'm going to add a position column to help us in some of the explanations. 18, which is my lowest value, is considered the first position, and 26, which is the next smallest value, is the second position. Once I have two of the numbers in for my position, I can drag them down the column and Excel will automatically iterate from 1 through 40. Excel has two versions of the percentile formula and two of the quartile formula. The difference between the two is how it looks for the position of your desired percentile. If, for example, we wanted to find a value that's at the 25th percentile, which is also the first quartile, the inclusive version of the formula, percentile.inc or quartile.inc, will use this formula NP plus 1 minus P to find what position that value is at. Our value would be between the 10th and 11th position. The exclusive version of the formula uses a different variation of the L sub P formula, n plus 1 times p. Excel uses these two different ways to find the location, but after that, the value is calculated using the same formula. The other difference between the two is that the inclusive formula will allow us to find the 0th position and the 100th percentile position. Exclusive excludes those two. If we tried to find the minimum position in the data and the maximum, it would return an error. Let's start with the minimum equals quartile. I'll select quartile.inc. If I double click on it, it will be filled into the cell. The first thing it asks for is the array. The array is the set of cells which contains the range of values that I want to calculate the quartile or percentile from. I'll select all of column A, and then when I click the comma, it tells me that my choices are 0 through 4, where 0 is the minimum value, which is what I want. Close the parenthesis and hit enter, and the value comes in at 18, which is what we expect to see. This is the minimum or the 0 position in my data set. Now I can drag that formula down, and all I have to do is go into each one and change this from a 0 to a 1, a 2, a 3, and a 4. For the exclusive equal quartile, double click to select, and then choose my column A, comma, and now you see that it tells me the only choices that I have are 1, 2, and 3. It will not even give me the choice of minimum. In fact, if I enter a 0 here for my minimum value and close parentheses, it's going to give me an error. I'll go ahead and copy this down and then delete the first and last values and change this to a 1, a 2, and a 3. Now we can fill in our percentiles, which is simply equal percentile, and you can see it's giving me choices here. I'll start with this inclusive, and I'll choose column A. I'm going to do exactly the same values that I did in the first box, and that means for this, I'm looking for the 0th percentile, or the minimum of my data set. That's what this K stands for. Close parenthesis and click OK. So I've copied this down. Now I can change this to 0.25 for the 25th percentile, 0.50 for the 50th percentile, and 0.75. Or I can use 75%, and either way is fine with Excel. And then the final, on the maximum, I put a 1 to indicate 100%. And I'll do equals percentile.exc. Select my first column, comma, 0, and it should give us an error sign because it's exclusive. It does not include 0 and 1. I'll copy it down, and I'll change this to 0.25, 0.50, and 0.75. You can put any percentage you want in the percentile formula. It doesn't have to be 0.25 or 0.50. You can put 0.9 in to find the 90th percentile. In this video, both the inclusive and exclusive methods of computing percentiles and quartiles have been demonstrated. In this video, I'll walk through the simple process of creating a box plot using Excel's new box and whisker chart, and then we'll interpret the wealth of data available from a box plot. This set of data represents the online investment portfolio values for 70 adults aged 40 to 50 years old. The numbers are in thousands of dollars. A box plot is now very easy to build in Excel. Select column A, go to Insert, Chart, All Charts, Box and Whisker, and click OK. We're almost done with the formatting. Let's change the title to Portfolio Value for Clients 40 to 50 years old. Let's also add values to our box so that we can see the numbers we're looking at. I'll go ahead and left click here, and on the plus sign, Data Labels. Now I've got the numbers showing up inside my box plot. I'll expand it a little bit. Let's look at the rich information that we can get from a box plot. First, you can see two measures of central tendency and immediately tell whether your data are skewed or symmetric. The median is the line through the blue box. The X is our mean. When the mean is greater than the median, we say that our data is right or positively skewed. The values will trail to the right of our peak. The top of the blue box is our third quartile. The bottom is the first quartile. The median, as you know, is the second quartile, and the difference between the first and third quartile is the interquartile range. If the upper value on the box is our third quartile, which is 316.9, then everything above that third quartile represents 25% of our data, the top 25%. But when Excel crunches the data for us, it looks for what values should be in that 25%. Anything outside of it is called an outlier. In this case, the interquartile range is 234.225. 1.5 times that amount is added to the third quartile value of 316.9. Our upper boundary would be 668.2375. When we look at our sorted data, the closest value below that is 645. All the values above this are called outliers. And as you can see, when we look at the data that's shown above the top whisker, which is also called our local maximum, we have those four values. If we don't have outliers, then the local maximum will in fact be the actual maximum value of our data. When we look at the lower whisker, we can see 3.3 is actually our lowest value in the data set. Therefore, we set the local minimum to be our smallest data value, and there are no outliers below it. Recall I said our data is skewed to the right? The outliers are a good indicator of that. So is the longer line leading to our local maximum versus the shorter line leading to the minimum, and the mean being greater than the median. In this video, we have walked through how to insert a box and whisker chart, also known as a box plot, and how to use the box plot to identify mean, median, first and third quartile, interquartile range, outliers, and skewness in a set of data. This video demonstrates how Excel's Descriptive Statistics output can be used to determine skewness of a data set. When data sets are graphed, they commonly display one of four shapes: symmetric, positively skewed, negatively skewed, and bimodal. In a symmetrically shaped graph, data are equally dispersed around the mean. forming a bell-shaped curve. A set of values is skewed to the right or positively skewed if plotted data show a single peak, but the values extend further to the right of the peak than to the left. Let's consider an example of positive skew. In this data set, a sample of 70 participants between the ages of 40 and 50 are represented by the size of their online investment portfolios in column A. Here is the descriptive statistics output for that column. As a reminder, descriptive statistics is found in the Data tab in the Data Analysis menu. Skewness is 1.45. A positive value indicates positive or right skew. Let's insert a histogram and take a look at the data. I'll select anywhere in the column, Insert, Charts, All Charts, and Histogram. And as you can already see from the preview image, this data is skewed to the right. As you can see, the values in the graph trail to the right. The mean is also to the right of or greater than the median, which we can see in our descriptive statistics table. The mean of 242.7 is larger than the median of 199.75. Now let's consider a negative skewed example. In this data set, we have the number of families who used a YMCA daycare service during a 30-day period, and we have a negative 0.67 skew. We will expect to see values extending further to the left than to the right. This example is not as significantly skewed as our last example. The skewness is a smaller value. Let's insert a histogram and look at the results. The mean of 42.7 is to the left of the median, or is less than the median, which is the peak of 44 in this third column, and values trail slightly to the left. In this video, we have demonstrated how to find skewness using descriptive statistics, and how to determine whether data are positively or negatively skewed using the skewness value in our descriptive statistics output. In this video, I'll demonstrate how to use the pivot table feature in Excel and convert the resulting totals into percentages in order to create a contingency table. The data set we're using contains a description of 33 diamonds currently in stock at a jeweler. Data are provided in terms of shape, size, price, and cut for each of the stones. Let's build a contingency table, also called a cross-tabulation table. This type of table is used to classify sample observations according to 2 or more identifiable categories or classes. In this case, we'll use the price and the cut categories. We begin by building a pivot table. Click anywhere in the data, click Insert, Pivot Table, and accept the defaults to have the table inserted in a new tab. In the new tab, I'm putting price in my rows and cut grade in my columns. I've dragged price to the values area. I'm going to group my prices into $5,000 bands. So I'll right-click, choose Group, change this starting at point. I'm going to use a nice round number of $500, and then I'll change it to a grouping of 5,000. And that gives me 5 classes, and then I don't need to change my column labels. Those are nominal labels and they don't need any grouping. Inside the table, I need to right-click in order to summarize the values by count. As you can see, the numbers that are inside the table are definitely not a count of how many diamonds fit into each cell. We know that we have 33 diamonds in our inventory, so our grand total should be 33. Summarize values by count. Finally, in terms of formatting, let's make this table a bit easier to read. I'll change the font to Calibri 12, and let's pick a more readable design for our pivot table. Clicking anywhere inside the table on Design, and you can see that there are a lot of choices here. Let's go with this choice. We have just built a contingency table. If this table represents a typical inventory profile for this jeweler, I could use my table to calculate various probabilities. For example, 3 out of 33 diamonds in stock are ultra-ideal cut. 25 out of 33 diamonds are priced under $5,500. However, Excel will do that calculation for us. Right-click in the data and choose Show Values As, and then change to percentage of grand total. Now each value in a cell is the percent that cell is out of the total of 33 diamonds. For example, 6.06% of the 33 diamonds are priced between $500 and $5,500 and are average cut. 75.76% of the 33 diamonds are priced under $5,500. In this video, you have learned how to use Excel's pivot table function to build a contingency table and convert the values to percentage of grand total.